All right, we are getting into designing experiments, and I can tell that you're as excited about this as I am. Probably not, because you don't even know what you're getting into. But step one, when you're designing an experiment, you impose the treatments. When you are doing an observational study, you observe what people choose. You can choose to drink coffee or not. In an experiment, I tell you to drink coffee or not. In an observational study, you choose to exercise or not. In an experiment, I impose that you exercise or not. I tell you what to do. Okay? In an observational study, you choose to take this medicine or receive this treatment. In an experiment, I impose treatments on you. Okay? And when we were in a study, we're wondering, is that a cause? Did this cause the effect? And in an experiment, it's the cause. It does cause the effect. We can finally conclude causation because of experiments. Yes! I'm like fist bumping and everything. Like I'm pumped that we can conclude cause and effect by imposing treatments and having a well-designed experiment. So what we're going to use is what's called completely randomized design. And there's 4 ideas in this: replication, random assignment, control, and compare. All right? Replication, I'm going to go into greater detail on each of these 4 ideas. So I'm going to zip through it right now. But replication really has it so that if someone repeated this experiment, they would get similar results. And that requires lots of subjects. All right. Random assignment makes it so that the 2 groups are both similar in attributes to my whole group. Not necessarily, this whole group is not necessarily representative of the population. These are volunteers, okay? And so we're losing the ability to infer up to the population. But for these subjects, these 600 subjects and these 600 subjects will both be similar to this because we've randomly assigned them to the 2 groups. And we're going to use the hat method for that again, okay? If we're giving them medication or a placebo, we want to control for other things that might help them to get better. Because if we want their temperature to go down, we want to make sure that they're not doing things differently, that maybe these people are all getting lots of sleep, or these people are all out in the warm weather, and these people are all in a cold basement like I am right now, or something like that. We want to control for anything else that might cause a drop in temperature, okay, besides the medicine, so that when we compare the drop in temperature, the only remaining possible cause that could have caused the drop in temperature isn't any other conditions, but it is the treatment of the medicine that they actually received is what caused the drop in temperature. All of these are leading to cause and effect. Okay, you want sufficient people so that the results we get couldn't have been achieved just by random luck. We want random assignments so that we don't have bias and have one group that's automatically going to do better in dropping their temperature than the other, right? If I took people with the highest fevers and people with the lowest fevers, well, these people have more room to drop in temperature, okay? So that would lead to a comparison of drop in temperature, but it wasn't caused by the medicine. It was caused by my selection of groups. And controlling to remove all other possible variables that could have caused the change in temperature. And here, the idea is we get to compare the response variable in its purest form where we know we've isolated the cause. All right? That is experimental design. I'll see you in replication, random assignment, control, and compare soon.